Hi everyone! In this video, we'll take a look at how to deal with significant figures, or sig figs, following calculations of addition and subtraction. Having to keep track of sig figs is one of those things that can seem like busy work. But when we take measurements or use them in calculations, it is really important that we retain the precision of those measurements. In other words, we don't want to misrepresent the precision or reproducibility of our measured values or the calculated results. This is why dealing with sig figs is such a big deal. Now, while this video focuses on keeping track of sig figs during calculations, we can't do this unless we understand how to count sig figs and how to identify number of places in a measured value. Here's a brief review of the rules. Exact numbers never count when they're part of any calculation. We just ignore them. When we're counting how many sig figs we have within a measured value, leading zeros never count. And trailing zeros only count if there's a decimal point shown. It's the zeros where most mistakes are made, so it's worth remembering these 2 points. And finally, all other numbers count. If we have to determine places, we assess which digits are significant in the value and locate the one that is furthest to the right, then label that position. You'll see here that I will count decimal places when the final sig fig is to the right of the decimal point, and use the formal term for place value if the final sig fig is to the left of the decimal point. For calculations involving any combination of addition or subtraction, we want the fewest places. Our strategy is to label the places in each value. If the value is exact, we'll note this as exact so we remember to ignore those places. We'll then identify the value having the fewest places as the one where its final sig fig is the furthest to the left. Then round the calculated result to the fewest number of places coming from these values. With addition and subtraction, deliberately remind yourself of the rule about fewest places as you head into a calculation. I really do believe that actively labeling the places in each value makes this process a lot easier, and you'll be less likely to fall into the trap, which is to count sig figs. For our first example, we want to do the calculation and round to the proper number of sig figs. We're not told that any value is exact. Because this process is addition, we need to count places, not count sig figs. In our first value, 17.01, the 1 is our final significant figure, and it is at the second decimal place, which means this value has 2 decimal places. In our second value, the 0 is significant because there's a decimal point shown, and this value has 1 decimal place. And in our final value, 219.385, the 5 is our final significant figure. It's at the third decimal place, and so this value has 3 decimal places. The rule for addition and subtraction is to round to the fewest number of places, and so you can see from our values that our fewest number of places is 1 decimal place. I hope you can see here how much easier it makes it to keep track when we actually write it down. So to do the math, 17.01 plus 4.0 plus 219.385 rounded to 1 decimal place gives us 240.4. Our next example is a subtraction, and here we are told that one of the values is exact. But we're going to go ahead and go through our process, and when we get to that value, we'll literally write the word exact underneath it. In our first value, 340, the 0 is not significant because there is not literally a decimal point shown. So our final sig fig is at the 4. The 4 is in the tens place. And I think for these place values, these places where we're looking to the left of the decimal point, it is especially important to write them down and to make sure that they're correct. I think that's where a lot of the confusion comes in. Our second value we were told was exact, so we're just going to write that down. The final result gets rounded to the fewest places, and we only have one place to consider here. So our final result gets rounded to the tens place. So doing the math, 340 minus 273.15 gives us 66.85 coming out of the calculator. We need to round this value to the tens place. So let's start by marking where that is. That's way out here. That's the only digit that we're going to keep. So when we do this rounding, we have to make sure that we're rounding to the proper place, but also that we're keeping the magnitude of the value. In this case, the number is basically 67. So we need to round this to that first digit. And when we do this, we would round this up to 70. So this value of 70 has the significant digit, the final significant digit, at the tens place.